as you are familiar, this is about integrating scikit-learn models into the .NET ecosystem. So first of all, please notify me that you can see the screen, that you can hear me well, so I can start the presentation according to plan. Okay, so today we are going to talk about the integrating of the scikit-learn machine learning models, and of course I'm going to show you some. I'm going to show you one demo, a practical demonstration of how we actually done this as part of our project. And I'm really excited to show you how the ONNX, the Open Neural Network Standard Exchange format, actually helps us in deploying the models within the .NET ecosystem. First of all, who am I? I'm Miodrag Cekic. I'm working as a senior .NET developer. So I'm coming from the Microsoft .NET area, and in the same time, in parallel, I'm working as an ML researcher and enthusiast. Currently, I'm doing and finalizing my PhD thesis in the bioengineering field. And also, in the same time, I'm working as a technical trainer here in Macedonia, and I'm part of the Macedonian .NET community, also here in Macedonia. So these are my my profiles. You can find me on LinkedIn, Medium, also on ResearchGate, where I'm publishing my articles. I would say this is the academic perspective, and also you can find me on SpeakerDeck and GitHub. I will share the links from this presentation as well. So how we are going to organize the session today? I will try to just briefly cover some theoretical concepts and the background behind the ONNX and our story. And of course, we are going to discuss the integration demo. I will try to integrate everything, including the modeling in scikit-learn, Python, and of course, the integration with the Microsoft .NET ecosystem. So first of all, I'm going to present the cover story of our idea and also to show you our prototype so far, and discuss about the ONNX, how ONNX actually fits in our picture. And this will be along with the dataset overview and the integration demo of the practical implementation of our product so far. First of all, we just discussed with Brandon before this presentation that I really like this Fred Brooks idea about that there is no silver bullet in the single development in architecture or just in the way of thinking about the technology in implementing systems, because there are a lot of tools, especially today, there are a lot of tools, there are a lot of frameworks that are providing different options and opportunities to implement the things. But in the end of the day, it's up to us what are we going to use and how we are going to build the system. And the most important thing, the system that would be working with the up and running at the end of the day. So our cover story is about, we thought about lead scoring. So I'm part of a team that is working in the field of digital marketing. So we have some expertise and business domain knowledge about this field, about the marketing methodologies, about the marketing strategies, and the lead generation process in general. So I would say that we are working, we took this business domain knowledge and tried to implement a complementary tool that will help to the marketing and sales team in the process of automizing the lead scoring process. And the lead scoring, by definition, is just a methodology for ranking leads or ranking prospects or just ranking potential clients and emphasizing or just analyzing and giving a sense about the potential of their sales readiness to the company. So basically, in its simplest form, the lead conversion process is going like this. We have the leads, we have the prospects. These are the businesses and the people who are actually who can be our clients. So it's our aim and our mission to just get them, onboard them on our services and products. And we are actually recognizing, our idea is to recognize the hot leads which are actually the highly interested leads in our products or services, and convert them in paying customers. Of course, this hot leads area can be divided in warm leads, cold leads, but it's beyond the scope of this presentation. We are not going to talk about the lead conversion process in details. This is the basic idea. We have leads, we need to turn them into clients and paying customers, and we are going to implement a model about that, because we are automizing the way of doing the lead scoring and the lead generation process. But you would say, why machine learning after all? Because we thought about this, and we actually address the following aspects that are really directly related with the machine learning. So, for example, we are witnessing that we have a big amount of data. Why? Because the digital marketing, the lead generation, and the sales team are in fact generating a lot of data, a big amount of data. So here we have this buzzword, big data. So a lot of data that is generated regarding the different processes and different marketing strategies that are specific for the companies. Also, we need a predetermined structure format of the data, but the digital marketing, lead generation, and sales teams, after all, are just generating data. So we actually saw that in some companies there are teams that are retrieving and generating the data in Excel. Some of them are just copying the data in Word. Some of them are using some kind of CRM. But after all, we need a predetermined structured format. And also for the lead generation process, we need the historical data. So when we have a label data, when we have the need for the structured format of the data, and of course, when we are using the historically generated data, then we are talking about supervised machine learning approach. So we get a sense that we can use the supervised machine learning approach here. And of course, additional aspects besides this is that the machine learning is improving and boosting the lead conversion process, because we are going to provide a tool that would maximize the power of the sales and marketing teams. And in the same time, we'll retrieve additional data insights, like deep knowledge from the data by the model, the machine model interpretability, by, for example, interpreting the most important features that could be very interesting regarding the process of collecting the data, regarding the process of just fine-tuning the marketing strategy and say, okay, we have a lot of data, we have a lot of potential customers that are coming from our official website, but in the same time, we don't have a lot of leads that are generated, for example, from some kind of form or, I don't know, some advertisement. So we need to analyze this and just fine-tune the things here in order to retrieve more data. So from idea to prototype, we say, let's give it a try. And as I mentioned before, we aim to automate the lead generation process, or providing a complementary tool for making the lead generation process to be more performant and efficient, to maximize the lead generation efficiency of the marketing and sales teams. So we've come up to this prototype. I'll briefly explain so you can get the idea about this. So first of all, we have the data sources. Our idea is to retrieve the data from different CRMs, from different relation database management systems, from different APIs, files, and so on. And this is actually our team that, first of all, we use the business knowledge, the expertise in the field of marketing, of digital marketing and lead generation. So first of all, before the modeling is actually applied, we are doing typical traditional data science techniques, which means data understanding, cleaning, exploratory data analysis, and data preparation. But for the data science techniques, I would say that I will mention these three, and we'll emphasize the exploratory data analysis, because implementing the exploratory data analysis with this process, we are retrieving we already are retrieving the data insights. So we can recognize some patterns in the data. And that's why from the exploratory data analysis, we are trying to generate the initial marketing and sales team report. So we actually can provide and find patterns in the data, even in the exploratory data analysis process. After that, after the data is cleaned and prepared for modeling, we are actually building the machine learning algorithms and pipelines. We are building the models, evaluating, fine-tuning, doing some techniques for example, hyperparameter tuning, and so on. And we are merging the machine learning model summary with the previously retrieved data insights in order to provide a data insights report to the marketing and sales team, and also provide insights about how we are collecting the data, which data is actually significant for this process, and how we can improve our lead generation process. So if we have here the client environment in the ecosystem, they are going to get two aspects from this prototype. First of all, a report about the insights, a report about the data analysis and what is actually happening with their data. And of course, after the deployment of the machine learning models, they are going to get a tool that will be automated lead generation tool, which can be, for example, hosted on API and used by different environments that could be internal or external systems to the company, or I don't know, maybe just some application that would be hosted outside of the company and the business. And our actually the most important challenge that we got is in the deployment part. So I would go briefly into the solution so you would see, but we actually kind of feel challenged regarding how we are going to provide and deploy the model so these clients and companies can use. And in this situation, actually, the light at the end of the tunnel was ONNX. ONNX is the Open Neural Network Exchange standard. It's a file format. It's something that is representing the models in the form of graphs. And actually, is the most important thing is that it's framework agnostic, which means that it could be shared between different machine learning tools and frameworks, and it can be, of course, imported and analyzed, and in this situation, like integrated and deployed to the final solution. So I've mentioned here the official website, the GitHub and tutorials about the ONNX. I will open them on the browser as well. So besides the ONNX, like the standard, we have the ONNX runtime, which is very important because this is the set of APIs for working and integrating to the target environments. And the ONNX runtime, after all, is a cross-platform and high-performance engine, not just related to the software, but also related to the hardware and hardware acceleration part. So ONNX runtime is very important because we are going to build and run the models, for example, in Jupyter Notebook, and of course use the same runtime and run the model in Microsoft.NET. So first of all, I would just go here. This is the ONNX Open Neural Network Exchange official website. You can access here the documentation, and of course, because it's open source, you can find it the GitHub and just drill down what's happening there. And of course, what I would like to emphasize, this is the ONNX runtime. This is the Microsoft ONNX runtime GitHub, so you can drill down the code. It's open source, as I mentioned. But the most important thing here is that when you're going to build some model, this is very interesting aspect of from where we can actually start. So in the ONNX runtime, we have the platforms, APIs, architecture, and hardware acceleration that are currently supported by the ONNX runtime. So for example, if I choose here, this is an interactive window here. So if I choose Windows as a platform with supporting the C# in 64-bit architecture for CUDA hardware acceleration, you see here that we immediately got the NuGet package that we can use, and of course the documentation that can be used in order to speed up the process of integrating the ONNX runtime in our solution. So this actually, this saying here that get started easily is right, and it really helps us in building our solution. Okay, so also what I would like to mention here is one brilliant article by George Nowak about the technology gap context. So from one side we have the data science, from the other side we have the application and the application development in general. The data scientists are actually very often using data science tools and very often using Scikit-learn, Python for creating models, for model evaluation, data preparation, data cleaning, re-evaluation of the model, rebuilding of the model, and so on and so on. But the really challengeable moment is coming when we need to deploy the models. So what when the model is ready? How we are going to integrate that model in the client system? So in this case, we are dealing with ONNX. So we are taking in consideration ONNX as a format and trying to like unify the model and trying to import, read that unified format in our system. In this case, I'm going to show about the .NET, and of course build, deploy, and test in our environment. So I'm really recommending this article because it's giving the sense about the technology gap or discrepancy between the tools and the frameworks. And of course, I would like to start with our solution. So because we have to integrate the model from Scikit-learn Python directly to the .NET ecosystem. And first of all, because it's data-driven marketing, we need the data. So we actually get the data from a lead scoring dataset that is publicly available on Kaggle. We also get a permission for using this dataset for, it's not about commercial aims for now, but we are trying to build our solution. The prototype is built upon this data. So you can access the data here in the lead scoring dataset. It's about historical data that are retrieved for imaginary company X Education that is trying to sell or to offer an online content for professionals and students that could or could not participate in one or multiple courses. So it's a standard learning platform, I would say. And the data, it's very interesting. It's generated using different sources like web pages, landing pages, forms, and so on. I would briefly open the data just to give you the sense about what's happening here before I proceed with the demo. So I think that it will be open. Just a second. I would quickly copy the link, try to open directly. Okay, so here it is. Here we have the data set. As you can see, it's publicly available. We have 37 columns and 9,240 unique rows. So a data set that is enough for building a prototype. We have different fields that are actually generated by the web forms, by the official website, by questionnaires, but also fields that are generated by the marketing and sales teams. Okay, so for the prerequisites, of course, we need to implement data cleaning, exploratory data analysis, and data preparation in order to implement the machine learning modeling. I will show briefly some of the techniques. And of course, we've come up to the supervised machine learning approach. I mean, we can implement regression for the lead scoring scenario. We can implement classification for the lead decision, because instead of giving the scores, for example, a 0.85 that this lead would be converted or not, we can, of course, just provide a score that this lead would be or would not be converted. The main idea with the lead scoring is maximizing the efficiency of the marketing and sales team. So, for example, if we have companies that have just a few people that are working in this field, so these are not big companies, but they are limited in human resources, then these kind of tools can help and boost their performance, because, for example, if we have 1,000 or 2,000 or 10,000 data about leads that we are generating on a daily basis, then these people can focus on the most important and most potential clients that would be converted to paying customers. That's the main idea behind this process and this concept. So let's get rolling, of course. And before I open the Jupyter Notebook, I would just like to share that I'm using the Conda distribution, Anaconda distribution for Python computing. I'm going to use the Jupyter Notebook for building the models using Python-based Scikit-learn library and, of course, Python language. And on the other side, I'm going to show you that I'm using the .NET .NET Core version 6. And of course, the most important packages related to the ONNX, Scikit-learn to ONNX version 1.9 and the ONNX runtime version 1.8.1. Okay, so I would open now the Jupyter Notebook. This is a Jupyter Notebook workspace, the document, when I'm actually going to show you that, first of all, I'm sharing this for the guys that are actually, this is like a template that we are building, that we are using in order to cover the techniques for data analysis, for data cleaning, the exploratory data analysis, and so on, for different regression and classification scenarios. And I'm going to share this on GitHub, of course. And what I would like to say that we've implemented here the standard implementation of the data wrangling, I would say, libraries, and of course the Scikit-learn library and the performance evaluation metrics libraries and packages that we are going to use. I would briefly go to the solution, not spending much time. I'm going to emphasize the demo and concentrate on the demo, of course. Here is the data set. So we are dealing with, as I said, 9,240 entries with 37 columns that are coming with different types. And of course, as you can see, we have a few columns that have a lot of null values. So we've implemented here some null values technique, how we are going to avoid them, how we are going to just wrap that columns, maybe exclude some of them, and so on. And of course, we divided the columns, the features, into categorical and numerical in order to, of course, do the exploratory data analysis on different types of the features. So as you can see here, we are doing some data visualizations in order to find out how we can abstract and how we can actually merge some of the values in the fields. And of course, we are dealing with the outliers here. And I would just briefly scroll down and show you that, of course, we are implementing a technique for dummy values in order to convert the categorical values into the numerical ones. And after that, we are actually generating the lead scoring data process data set, actually. So here you can see that all the features are in numerical, converted in numerical values. And of course, I'm not going to in details to show you because you have the presentation, you have the data set publicly available. You can try even your algorithm there. So what is here important that we are actually analyzing the correlation between the features. We can create here a heat map, of course, about the correlation about the features. And I'm not going to emphasize the phase of building the models. So far, we actually built a great model with over 82% accuracy, but it's not the point. I'm just prepared this solution to show the concept, to show the proof of concept that we are actually dealing with. And I'm going to just standardly split the data into training and test set using the ratio of 0.7 to 0.3. And of course, I'm doing a technique for redundant feature elimination and trying to eliminate immediately 20 features. So these are the most important after this procedure. These are the features that we are going to deal with. And here is the important part. This is the function for building the logistic model. Actually, we are going to use the logistic regression for classification purposes using the leap linear algorithm and fit with the data that we've already split. And of course, here I just point the calculation of the variance inflation factor I will show also a solution where this is the heat map. Besides the variance inflation factor, we actually try to implement a generalized model. I will show you in another document. But the most important thing I would just emphasize here is that we try to eliminate a few more features that are related to the correlation between them. So as you can see, I think that we've built the first model. Here is the second model, and in the third model we actually get these values for the variance inflation factor. But in the same time, what I would like to show here that this technique can be also used with calculating the p-values, doing some statistical analysis. That's why I'm sharing that this is just a proof of concept. You can of course implement here different tools, different techniques in order to improve the performance of the models. But for now, we have the logistic regression model 3, and we are using the predict proba implementation, the functionality. Why? Because we are really interested in retrieving the probabilities of the leads that are going to be or not going to be converted as customers. So we are using the probabilities for 0, 1, I would say. And of course, I'm doing the evaluation of the model, which is with this performance metrics, which I'm not caring about in the context of this demo. But as you can see, this is a pretty good model that is giving 0.76 accuracy on the test set. And I'm using the pickle for serializing the model and just saving as a lead scoring regression model PKL or pickle format. So now what I would like to show you that I'm actually getting the model. I'm getting the data here and just doing the splitting. I'm just emphasizing that we've done a simple split of the data, nothing special. So now what is the most important here part is that I'm going to use this lead process data. Okay, so this is the data that is processed and also that is saved here in Jupyter Notebook. So this is the data that is prepared for building the models. And our next aim is, of course, to build the ONNX. So we need the ONNX format in order to deploy the model in the Microsoft.NET ecosystem. So now what I'm going to do, we have the data here. And now I would like to just load the lead scoring model. I'm going to load with pickle.load and open it directly as lead scoring, just a lead scoring regression model. This is the third one. We are going to build the model just to read. Okay. So pickle is not defined, so we can just import pickle. Okay. So we have the model, the pickled model here. And of course, now what we need to store as ONNX format. But first of all, I would like to show that this model is actually working. So we have here, we can just use the model, of course, lead scoring model, and we can use the score functionality on the X test of features. These are the most important features we retrieve, and the testing data. So the result would be 0.76. Okay, doesn't matter. So now what can we do is we need to implement the ONNX format. So I would just get from SK to ONNX package and import here the convert scikit-learn model. This is the scikit-learn to ONNX package that you can find and installed with pip. Of course, you can find here the documentation, the installation process, and the most important thing that is supported by Microsoft. We have the scikit-learn, and of course, I have the code snippet for implementing the flow tensor type that we need to for the ONNX model. What I would like to share here before doing any kind of saving the models into the ONNX format, I really recommending scikit-learn ONNX that supported converters from, first of all, I would just import the SK to ONNX and SK to ONNX supported converters from scikit-learn. This is the list of all algorithms that are supported by the ONNX and the ONNX runtime at this point of time. So you can just scroll down the list. It constantly it's getting bigger and bigger. But of course, if you have some different algorithm that is part of the scikit-learn in Python, you can use the documentation for the ONNX and try to build up a wrapper about this algorithm and implement edit as part of this list. But the most important thing is that we are using the logistic regression, which is of course part of this list. And we are also, for the lead decision scenario, we are using the random forest classifier. So of course we have here like inbuilt by default. So we are good to go. This is very interesting comment that I would like to emphasize about the converters and should be checked before the actual machine learning is done. And now let's just import the ONNX runtime, and I would say okay. So we have the ONNX runtime, we have the ONNX. We check the version. I mean the supported algorithms. For example, here we have the scikit-learn random forest classifier. We have the logistic regression as well. So now what we are going to do, let's ONNX model path, just define one path where we are going to store our lead scoring model with the extension of ONNX. So this should be the path. I'm going to save it here where my document is living, my workspace is living, and I'm going to define the number of features. So if I try to see the number of features that I have now, these are 18. So number of features, this local variable would be hardcore to 18. And I would say that we need the initial type. We need the schema for the ONNX. The schema is actually a list of feature input. This is very important how we are going to name it because it will be important for the integration process. And here I'm going to use flow tensor type of none for the output and none features as part of the schema. So this initial type is just the schema. So we are saying here that we are going to use a feature input, a schema for the ONNX model that is built of. We are not interested in actually the output, but about the shape of the features. How many features we are going to use? That's very important for the model. And of course, we are converting them in flow tensor type. We can have multiple inputs. Of course, it is supported, but in the same time, we can convert them. For example, in this situation, I'm converting them in float tensor type. It's a classical float type. And now we are ready to actually build the ONNX using the convert scikit-learn. Okay, so using the convert scikit-learn, we can build a model, and I would like to show here that convert scikit-learn is actually the signature of this function is the model itself. We need the model, and of course we need the initial types. I'm going to use the initial types that I actually built previously. So we have the lead scoring model, and we have the initial types as initial type. Okay, so if I try to see the type of the ONNX, it's model proto. Okay, so if we search for model proto directly on Google, we can find that it's part of ONNX, and this is the explanation and documentation about model proto. So now we have the ONNX format. What can we do here? I have a snippet just for saving the model path. We are using the model path and saving this model directly into our workspace. So here it is, lead scoring model ONNX. So we have the Scikit-learn Python-based model converted in ONNX format. Now we can use the ONNX runtime if we would like to just run the model and see that it's actually working. So for this we need inference session. So we can use the runtime inference session of our model, and our model is actually living at the path that we've defined before, ONNX model path. We have the session, and as you can see, the session is of type. The session is of type inference session coming from the ONNX runtime. Okay, so now what can we actually do here is to define the input name that is coming from the session. So I would just get the inputs from the session, input name. So the input name, just to show you, is the feature input. That's the feature input, and of course we need the this should be taken in consideration when we are doing the deployment and the integration, because should be also entitled named same in the .NET solution. So now we have here the feature input. We have the inference session. Let's give it a try. Okay, so let's name this as prediction ONNX and just run this in inference session. How we can run the inference session? We have here the signature, output names. We are not dealing with output names. We are not interested in the output names, but we need the input schema. So here I will just say not interested in the output names, but interested in dictionary of input name, which would be represented by the X train of features. This is our training set, and this should be, of course, converted into NumPy float 32. Okay, so if I run this and get the first portion, Python X, you see here I'm getting the is converted or not converted values from the model, and of course I can run the same line here, but get the second portion, I mean with index 1, and when I try to print this, we get the probabilities. Okay, so these are the probabilities of being converted or not being converted regarding the specific prospect. And this is everything done with the train data. We can of course use the test data here, and we are going to get different perspective. This is from the test data. So for example, for the first prospect, we have 0.83 probability of not being converted, despite the fact that 0.16 probability of being converted. Okay, so we're actually we retrieve this by using the predict prob method that I've showed before. And of course, it is very important because our solution is dealing with ranks, with weights. So we are using these probabilities of being or not being converted in order to define the specific scenario of the specific scenario and the actual weight of the lead. So these are the indicators for our lead. Okay, so because we have now the probabilities, you see that we have also the classical prediction. So I would say that this is actually running the inference session using the ONNX runtime within the Jupyter Notebook and Python within the Jupyter Notebook using the Python-based approach. Now, what is very important here is how we can actually get this lead scoring model. So the type of lead scoring model, as you can see, is Scikit-learn linear model logistic regression one. So we need to integrate this in the .NET ecosystem. For this purpose, what I'm going to do, this is a blank solution. I'm using Visual Studio 2022, the community edition. And I'll just create a blank solution here. Blank solution that would be titled as lead scoring workspace. And I'm going to just use my community group session. This is empty folder. Yes, I'm going to use this folder that I've prepared before, and I'm going to create the blank solution. Now what I'm going to do, just create a new project, which will be of type Azure function, the representative of serverless architecture, but Azure function because we can actually run this locally as HTTP, doing that with HTTP calls. So Azure function, that would be lead scoring func. So this will be the name of the function. Let's create and get the boilerplate code. We are going to implement this with .NET 6 framework, .NET Core 6 as HTTP trigger, and I would just leave the authorization level to function and storage emulator that is Azure related. So let's create the function. Let's get the boilerplate code. I have snippets in order to speed up the process here and show you the integration. We have the model in Scikit-learn. We have the ONNX format. So now what we have to do just to incorporate into the .NET ecosystem. So now I will delete the boilerplate code, just build a solution in order to validate that this is working, that I've not, that is not broken. Just a second. Okay, I think it's loaded now. I would just build in order to verify that it's working. Okay, so now we have the request. Okay, so I would open Insomnia just to create the request. I will use Insomnia. We can use Postman just for sending the HTTP request, but I'm going to create another workspace here, request collection, that would be practical ML.NET collection, okay, and create new request that would be post, and let it be lead scoring func. So of course we need a body of type JSON, and I'm going to pass here the code snippet that I have JSON format of all our input features. Okay, so these are our input features. Just to extend this, here it is. So model parameters objects, JSON object that is consisting of all input features. Okay, so if we send this request with values regarding our input features, we need to catch that request, parse that request, and use as part of our system, so to integrate our model. First of all, what I need here, I need to show you that we are going to use the ONNX Microsoft ML ONNX runtime package. So this is the package we are going to use. It is available on NuGet. And of course, you can install via the CLI. I'm going to install directly here by the NuGet package manager. We need this in order to run the inference session. So now we have the package, and we are ready to start implementing the solution, which I'm going to speed up using some of the snippets. So first of all, what I would like to create would be one simple, very simple class, ls lead scoring model parameters, okay? And this class would just explain our input feature set. Let it be just internal class. and I will just use the code snippet for incorporating here all our input features that we are going to use. So that's what this class is about. We have the class, so we are prepared to start with the .NET integration. What is very important here that I can take the request. So request, I need the request in string rec body or request body, and we have the request, and we can retrieve the body, but not in the stream format. So we need here to create like new stream just to get the string. Okay, so new stream. This is standard .NET implementation. New stream reader actually, just to get the string. New stream reader, and we need to read it. And we can use the async method and await this call. So now what we have here is the request body in the format of string. What we can use there, we can retrieve the data. How? Using of course, the JSON converter. Here it is, and deserialize this string. Deserialize JSON convert dot deserialize. Yes, deserialize object of. We need the request body, of course. Okay, so the data is of type object. I can say here dynamic to be actually executed and in the runtime. And here we have the data. Which data? It should be this data. So deserializing the request that we are going to send to the function. Now I'm going to use another code snippet because I'm not going to copy all the parameters, of course. Just to show you what I'm thinking is I'm creating the model parameters as object of the created class ls lead scoring model parameter class. And what I'm going to do it with this, I'm going to assign the values from the data, and my data is dynamic object of the deserialized request body that we are going to send to the API. In this situation, it's Azure function. And what is very important here is implementing input tensor. Okay, this input tensor is just a matrix. It's just the schema. What schema? The schema of the features that we are going to use for the models. So we are just implementing the schema of our input feature set, and we are set up with the input features, which is great. Now what we need to use the ONNX format. This is the moment. So I'm going to create here ONNX model path, the same variable for the ONNX model, and let me just go here, take this path, okay, and of course we need the lead scoring model ONNX. Like this, I'm going to interpolate the string, and we have the model path. So now what we have to do is to convert the lead scoring input object into an object of tensor float. So this is the input, and the next step that is very interesting is just prepare the input set using the ONNX runtime NuGet package for incorporating in our inference session. So list is coming from the generic. What I'm doing here, I'm preparing the features input in named ONNX value because that's how it is expecting to be. So just a conversion list of named ONNX values that are coming from the runtime package. And this is the feature input. This is the most important part that should be named as we actually name within the Jupyter Notebook. And of course, the input tensor, we need the data that we are sending in the API. The next step is creating the session. Okay, so we have the inference session of what? Of the ONNX model path. This is the same, you can recognize the same pattern here. We are creating the inference session using the runtime package. RT was runtime, ONNX runtime, okay. Where is it? I think it was here, yes. So we are using the inference session from the ONNX runtime to run the model. We are doing exactly the same in this scenario. This is the inference session coming directly from the ONNX runtime, And we need the session output from the inference session. This is the inference session of the ONNX assembly, ML ONNX runtime. Okay, so now we have the session input, and the session input is actually coming in this format. I will just start this solution, okay, just to show you and use the compiler. I will start this function. Let's first build the function, this Azure function. It should be working. One failed. Okay, I think that now I have just a second. Yes, unable to copy. Let me just close this solution. It's Visual Studio related issue that I recognized before the session. As a matter, I will try to fix it. Okay. If not, I'm going to show you the code, and of course, I would leave the code on GitHub so you can start on your own. Let me try to start the function. It happens always. Yes. Okay, let me try with again, just a second. If not, I'm going to try to implement using the code snippets. Once again, I really want to show you. Yes, okay, doesn't matter. Let me close this solution. Close this solution. I would create another one, just simply using next solution, lead scoring solution, and it should be here on desktop. Okay, select folder on desktop. Yep, and add new project, Azure function, function1, doesn't matter, .NET 6, using the same pre-format values. And what I'm going to do, use the code snippets, the same code snippets, just to install the package. I really like to show you. It's always happening with the demos. Okay, there it is, the package, and I would copy now the code. I have here the code, so we need the ONNX path. It, of course, and we have the input tensor. Okay, and we have the feature input, the model path. Okay, and we need to solve this one. If not, I'm going to show you one article with the implementation, but I'm really disappointed why it's not working. All right, so let me just put here kind of response message, and we need the ONNX model path. So I'm going to copy the ONNX model, lead scoring model ONNX. Here it is. Okay. Let me try this one. If we'll have luck here, it's something happening with the Visual Studio, but I think that I would bring this up. Doesn't matter. So when I was in creating the session, inferencing with session running, here it is. Okay, that's good. I'm owing you some minutes. Please stay here. Okay, so we have the function. This is the link of the function. Thank you. And I'm going to copy here directly in the Insomnia and trying to hit the debugger. Okay, Yes, there it is. That's good. So this is the integrated debugger from Visual Studio. We have the input tensor with values. These are all values that are coming from Insomnia. Okay, these are all values from the input feature set. We have the inference session from the ONNX model path that is defined in our folder. And now we have the session output. So in the session output, we have two outputs. The first one is the predictions, the standard predictions. The second one, as you can see here, the value of 0. Why? Because the first record from the training, from the test set was that it's not going to be converted. That's why it's 0. In the second one, we should get the probabilities, output probabilities that are coming from the predict proba implementation. And I can unwrap them here. They are. So we have the probability of converting or probability of not converting the lead. Let's just extend this code with unwrapping the message. So to be more clear, I'm using here, this is coming from the system link. What I'm using here, I'm getting the raw result in disposable name ONNX value from the session output of the first element, I mean from the index 1. And this ONNX value is actually a list, or actually a collection of disposable named ONNX values, the same values that were expected by the ONNX runtime from the raw result. And in this situation, in raw result value, we have the probabilities. And the probabilities here are the probabilities that we are going to just wrap as a dictionary of long and float. These are the values of being or not being converted. So now in the lead score, we should get the probability of being, okay, of being converted, because we are taking the first element. But what I'm going to show here, that we can of course get the lead score not converted, and this should be this record. Okay, so let me start once again, just to point the idea. So we have the Insomnia, we have the Azure function that is now creating locally. This is the link. So sending the request is coming to Visual Studio. So in the .NET ecosystem, we have here, we are executing, unwrapping the result and coming to the lead score. So the lead score for this prospect to be converted is 0.16. This is the probability which I'm identifying as a lead score. I can use it, it's relevant. And to not being converted is actually 0.83. Why? Because in the probabilities I've unwrapped this probability. So what I would like to say here is that we have here these probabilities. Okay, so I would just say like this, just to make the comparison and wrap up the session. So the probability of being converted will be, and I can use here the string formatting like this. Okay, so the probability of being converted will be lead score. Okay, this is the lead score that I'm going to use. While not being converted will be, and I'm going to use lead score not converted. Okay, so I would like to just show this message in Insomnia. Let me start the application. Let me remove the debuggers. Okay, please start. Yes, thank you. So it will be mapped on the same path we have here. Get or post request, doesn't matter. It comes from the definition of the Azure function. Let me execute and see here the result. So we have the result. The probability of being converted is 0.16, while not being converted will be 0.83. So I would like just to open the Jupyter Notebook. Let's just investigate. So if I use the X test of features, okay, I need to get the first one. Here it is. So the first record of the test set is all with zeros, just the second position is 1. So I'm sending actually this record, exactly this record to the model. And here it is, the value of 1, okay? So these are the probabilities that are retrieved from the same model, converted in the ONNX and integrated in the .NET ecosystem. What I would like to show you here is the results, which is very interesting. Okay, so here we have 0.8389, okay, 8948, and these are the values that are different. Okay, so we are expecting some minimal loss in this situation. And it's the same with the 16105 and so on. So we are expecting loss, but generally it's here. We can see this. So my point was to show you that using the open neural network exchange format, we can simply create a lead scoring ONNX model, okay? And we can also implement the runtime and run this model within the Jupyter Notebook. For example, this is very standard procedure for the data scientists, but in the same time, we can use this model and implement as part of another framework. This can be also done using like the Keras, the TensorFlow, and so on, but I'm using the targeting framework, for example. It could be Java, of course, but I'm using the .NET. So based on this ONNX model, which is created here, okay, based on this ONNX model, I'm incorporating this file format in the .NET ecosystem and building this simple solution, okay, building this simple solution where I actually creating the inference session, I'm running the session and retrieving the results, which in this situation are for single element, but of course they could be implemented and adjusted for a bunch. So we can send multiple records via API, via Insomnia or Postman. We can, of course, implement this as a web API. It doesn't matter. The most important thing is that we've used the Scikit-learn model. So what I would like also to share here is on GitHub. I would go directly to the presentation. So the key aspects of this presentation, I would mention the addressing discrepancy. This is the discrepancy between the tools that are traditionally used by the data scientists and not by the application developers. So now we're bridging that gap. And in this situation, in our scenario, is great because I'm coming from the .NET background, and I can easily understand what's happening in the .NET and implement this model as part of API or Azure function, or just to integrate as part of some hosted API that is part of the internal system of some infrastructure that is built upon on the Microsoft .NET framework. Of course, as I've mentioned, ONNX runtime is framework agnostic, so we can use for the most popular ML frameworks like Keras, TensorFlow, as I mentioned, of course, Scikit-learn with Jupyter Notebook. And the most important part that we have a cross-platform runtime engine. You saw that we actually built the runtime around the Jupyter Notebook document as well as within the Visual Studio and .NET ecosystem. Also, I would like to share that going here in the resources, you can find the code repository, which is hosted in my account, is as practical.net ONNX. Okay, so here is the repository, and you can I actually wrap the Jupyter Notebook document with all directions that you will need to start, and of course the workspace needed for implementing the .NET. Okay, so I can show you the .NET directly from here using the function. I've put here the comments. Okay, I've actually delete my data because you can try with your model, but this is ready solution that is building, just waiting for your ONNX model so you can use it. Previously created ONNX model, doesn't matter if it is with a Scikit-learn, it should be just ONNX model, and try to integrate within the .NET ecosystem. And let me just show you that this is the active session. I can go here in the community, in the Git profile. This is the repo. I would get the notebook just to show you what's happening here. I just copy in my community group session, so I can have here. This is the workspace that is on Git. I put here the techniques that we are using. I put the libraries and step by step how we actually build the ONNX model. Okay, so this is the logistic function, the predict proba algorithm, the functionality. We have here some performance metrics implementations, and so on and so on. The most important part is coming here, incorporating the ONNX and ONNX runtime related packages, and building, after all, building the model. So you can save the model like this and also run the inference session with already existing data, or, which is very important, that you can run and execute the inference session using additional data that is new, data that is newly generated. So please refer to this GitHub repo for the machine learning techniques in Jupyter Notebook, as well as in the Microsoft.NET ecosystem. And of course, in the presentation, I drop up a link from Towards Data Science, when I actually wrote an article about this conversion. So we can find here the background story and another implementation using another techniques where we actually retrieve, I think 19 instead of 18 features. Okay, you can see here that we are using some technique. Here it is. We have 19 features, so another approach for integrating. And of course, here you can find a link. If I remember, this is done with Postman. You can find a link with implementing this with Web API directly in the Microsoft.NET ecosystem using the official Microsoft documentation. And to conclude this presentation that I have here is already part of my speaker desk. Here it is. You can use the link and access directly to see the prototype and to see the cover story. So thank you folks for your patience, for staying here with me with the presentation. I really believe that it was very beneficial, that it was helpful. I also believe that a lot of you already are familiar with this concept, but what is very interesting here, that I'm showing you our proof of concept of a real practical implementation of our system. And I really hope that it would help you in, especially the code and the Jupyter Notebook document, in converting and just playing with the models, not just in the .NET ecosystem. You can try, of course, in another frameworks and tools, which is very important, which is actually great. And I would like to emphasize for the end that this implementation could be used in parallel with ML.NET, with the Microsoft machine learning framework. So we can import the ONNX models, we can execute the ONNX models using the ONNX runtime, and in the same time we can actually do machine learning in parallel using the ML.NET. Thank you once again for your patience and your time this Friday.
Awesome. Thanks so much, Miodrag.
Yeah, thank you.
Yeah, I think, and I do appreciate you including the Jupyter Notebooks there, because I know we can use tools like Netron to sort of peek into the ONNX models, but I always find it's way more helpful to have the notebook and the Python code that generated the model than just Netron by itself. So thanks for including that.
Yes, you're welcome. So actually, as I shared, you have the code generalized. You can use even with other algorithms, but before use with other algorithms, just use the command in order to see if that algorithm is supported by ONNX. As soon as it's supported, you can use the inbuilt behavior and just generate the ONNX file and try to build in your production or just proof of concept systems.
Awesome. All right, cool. Thank you so much. And this will get posted up to YouTube shortly. And thanks everybody for joining us.